Greetings, friends. My name is John Gabriel, and this is the New Calculus channel. So if you'll recall, last time I talked about Cantor's bijective cardinality, and also in this video I'm going to talk a little bit more about it to show you that it's actually an entirely useless concept and that it leads to contradictions. So let's begin. So you'll remember that I showed you in any circle, doesn't matter what the size of the circle is, the number of radians is always the same, right? So if we take any angle and rotate it, we're always going to have a length, a distance, and these numbers here are not the actual distance, they're approximations, because a lot of the distances on the circumference of a circle cannot be measured. Okay, so it's a fallacy that there is equinumerosity between this magnitude or this distance and this distance, because there are distances always on this distance that are not found on the red distance. So I'm going to leave that as it is, and I'm going to go now to show you that in another famous mapping, this mapping here, it's actually the mapping of the interval minus pi over 2 to pi over 2 between these dotted lines. It's mapped supposedly to the interval, if you could call this an interval, because it's not even a proper interval actually. So there is no such thing as infinity, let alone minus infinity and positive infinity. So it can't be an interval, but somehow this is mapped onto it. And the idea is entirely bogus and leads to contradictions, as you will see shortly. So, again, if two sets are equinumerous, two sets x and y, according to the mainstream definition, there exists a one-to-one correspondence or bijection between them, okay? Meaning that there is exactly one element, x of x, with the function of x equaling to an element of y. So, flags do not imply equinumerosity. It doesn't matter how many flags you can place along the circumference of a given distance. You can always have infinitely many supposedly flags between them. So to talk about equinumerosity in terms of flags is a particularly useless concept, and that's what it means. That's the only way you can have this bijection, okay? Because if you look at this tangent function, which is in blue here, you'll see that it takes some distance, which I'm marking as the x-coordinate of this green point in radians, and gives you the tangent function, which is some distance y on the blue function. So this here is not the same as what you see here in green, being equal to approximately some y distance on the function. Okay, it's not the same at all. Both of them start off as 0, 0, which is measurable, and then somehow you continue to cycle, and of course you know that as you reach pi over 2, this here becomes infinitely, or supposedly infinitely large, right? So the idea is that you cannot reach pi over 2, but somehow you'll see now that as we're cycling with that green ray and we're approximately at 2 pi, all that happens is it will recycle back again to where we started. So you'll have 0.1354 radians again, and it will just continue. So we've already covered the entire distance of the circle, okay? The entire distance, which is also equinumerous to infinity, right? The entire distance is 2 pi radians. So as you can see, this is really a counterexample to this definition up here. Moreover, the reason this here is not the same as this expression here is that all distances must have a name. That is, they must be well-defined elements, right? We must know what they are. We cannot talk about indistinct elements as flags, which mark certain distances. We must be able to reify the distances in terms of coordinates. And as you know, there is always a flag between any two flags, and so on. So it's not possible to name every one of those elements, so-called elements. And you cannot talk about indistinct elements in this definition, because in this Cantorian garbage definition, there is exactly one element of X with one element of Y. Okay? So that's what I wanted to show you, and I'm going to close off this video by telling you that you're wasting your time studying bijective cardinality. There is no such thing as A-left 0 and A-left 1, 2, and 3. That's all a bunch of BS. And it really leads nowhere, has led nowhere in the last, how many 100 years, 150 years. You're wasting your time with this sort of thing. And mainstream academics are perfect cranks because they subscribe to this absolute rot. So if you haven't already subscribed to my channel, do subscribe. Spread the news of this channel. Tell all your friends about it. And I hope to be producing another video sometime soon and talking to you about another interesting topic in mathematics. So, till next time, I'm John Gabriel, and this is a new calculus channel. Goodbye.